I'm going to explain a bit more about how this ideal gas law comes about so we can be more familiar with its uses. I'll write it down here again. PV is equal to nRT. This law did not just appear out of nowhere. It comes from combining two experimental observations. Now let me draw another box. Let me draw another box. Now this time I want to have one side of the box movable. Okay, I want to have one of the walls made so that it can slide in and out. So like a piston. So say I have a piece of stick there, and I can move this up or down. Okay, by applying some pressure here, I can push it down. And if I apply some pressure, the volume should decrease. The volume should decrease. So in this box, I have lots of oxygen molecules, for example. Okay, so that's my oxygen. Okay. So if I apply some pressure, okay, maybe I'll call it P. If I increase the pressure, it will decrease. Now, and I can also measure a temperature. I can just put a thermometer next to it, maybe stuck on the wall or maybe even inside. If I have a glass box, I can look inside and see the temperature. So, okay, so I can measure the temperature. I can kind of measure the pressure as well. If I know what is the force I'm applying on it. Like maybe if I apply this force by putting a weight on top of it, for example, then I can just divide by the force by the area to get the pressure. And volume, of course, I can just measure by using a ruler to measure the length, breadth, and height of this box and calculate it. So it's in a simple setup like that. It is not so difficult, all right. But of course, it would be tricky if you want to make it more accurate. But for now, let's accept that it is possible, and even you and I can do it if we spend some time to make up such a box to measure the pressure, volume, and temperature. Now, many years ago, as many as maybe a few hundred years ago, a scientist by the name of Boyle, B-O-Y-L-E, he did a similar experiment where he measured the pressure, measured the volume of some gas as he increased its pressure. And what Boyle did was this: he kept the temperature fixed. So the temperature in his experiment was constant. Okay, he did not maybe he did not do very much, just not heat it, just leave it in the room temperature and slowly increase the pressure. Now, okay, and what he found was this. As he changed his pressure, he measured the volume. So he made a list of his. He wrote down his numbers. Okay, and he plotted a graph. Right, he plotted a graph of pressure against volume. Pressure against volume. PV. Okay, so maybe I'll put P there and V up there. Okay. So what he found as he plotted his points was a graph that looked like this. It was a curve. So we found a curve. What this tells us is that when the pressure is low, the volume is big, and when the pressure is big, the volume is low, which is what we would expect from what I described just now. If you push down harder, the volume would be smaller, right? You will compress the gas. So this graph is it might look unusual if you see it for the first time, but it makes sense. It makes sense. So okay, and next thing Boyle did was he found that this relation follows a rather precise formula. And he found that when he for each of this value, each of this point, you can imagine that let's see, each of this point will correspond to a certain value of the pressure and a certain value of the volume. So I'll just say maybe in this case is say 200 Pascal of pressure, and maybe that is say 0.0015 meter cubed of volume, for example. Okay, and he found that when for each pressure that he applies, when he multiply the pressure by the volume, and get a certain answer, he found that if he do it again for another pressure and another volume, and multiply the pressure, that new pressure and the new volume, he always get the same number. In other words, he found that pressure times volume is always a constant. And I suppose he must have repeated this for other gases, maybe nitrogen or some mixture of gases like air or carbon dioxide. And he found that in all of the cases that he did, maybe most of them, the pressure times volume is the same. It always gives you the same number. Okay. Now, if you have two numbers and you multiply them together, you would always. But if you have two numbers, two variables multiplied together, and you find that it's always a constant, always a fixed number, then the graph of those two variables, when you plot those on the graph, it would always be a curve that looks like this. Okay, if you have learned this in mathematics, you know, like if you have x times y, if two variables x times y is always equal to 1, when you rearrange that, you get y equals to 1 over x. And when you plot y equals to 1 over x, you get a graph that looks just like that, a curve that looks just like that. Now, this relation, that PV is a constant, is now known as Boyle's law.